Hello everyone, welcome to Chemistry Eduhub channel. Today we are going to talk about the second type of bond, that is covalent bond, which is the most important type of bond. Okay, now covalent bond is formed by the sharing of electrons. That too, equal sharing of electrons between the two atoms. So covalent bond is formed by the equal contribution of electrons and mutual sharing of electrons between two atoms. This is the definition of covalent bond. This covalent bond is mainly proposed by the scientist Lewis. Covalent bond is mainly formed between the two nonmetals. Nonmetals which have less electronegativity difference, one with less electronegativity, the other one with more electronegativity. That means this difference is not much. The difference in the electronegativity should be less than 1.9, or the difference in electronegativity is almost equal to 0. In these two cases only you can expect the covalent bond formation. So when can we expect the difference to be almost equal between the same or similar atoms? Between similar atoms, the electronegativity difference is almost 0. Between two nonmetals which have very less difference of electronegativity, also you can expect the covalent bond formation, where both the atoms contribute, two atoms contribute 1 electron each equally and share those 2 electrons among themselves. Share the 2 electrons equally. That means the electrons given by one atom is 1 and the electrons given by the other atom is also 1, and these 2 electrons belong to both X and Y equally. Such type of bonding is called a covalent bonding. So generally the sharing takes place in pairs. If the two atoms share one pair of electrons, then a single bond is formed between the two atoms. Suppose if the two atoms share 2 pairs of electrons, then a double bond is formed between the two atoms. And suppose if between the two atoms, if 3 pairs of electrons are shared, then a triple bond is formed. So 1 pair is 2 electrons, 2 pairs is 4 electrons, 3 pairs is 6 electrons. Accordingly, a single bond, double bond and triple bond are formed. This type of bonding is not possible in the case of ionic compounds. Suppose if the bond is formed between two similar atoms, then such bond is called non-polar covalent bond. Non-polar covalent bond. For example, between two hydrogen atoms if the bond is formed, or between two nitrogens, between two fluorines, etc. Between two same type of atoms, if the covalent bond is formed, such bond is called non-polar covalent bond, where the electrons are equally shared between the two atoms because their electronegativity is same, electronegativity difference is almost 0. Suppose if the bond is formed between two different atoms, then such bond is called polar covalent bond. Polar covalent bond. What is polar covalent bond? For example, if you have HF molecule, hydrogen will have less electronegativity and fluorine will have more electronegativity. In such case, the electrons given by hydrogen and fluorine will be more towards fluorine. Then hydrogen will get partial positive charge and fluorine will get partial negative charge. Such type of separation of charges is called polarity, and hence HF molecule is called as HF molecule contains polar covalent bond. Lewis scientist explained the covalent bond formation using Lewis dot symbols. He gave Lewis dot symbols for different elements and explained the bonding in different atoms. So, electrons that are present in the valence shell are only used for the bonding. And these electrons in the valence shell are shared. So, a covalent bond is formed by sharing of electrons in the valence shell or the outermost shell, and the bonded atoms get octet configuration by sharing of electrons to get stability, and these electrons in the outermost shell are represented by dots or with cross symbols. Let us understand the covalent bonding in homoatomic molecule using the Lewis dot symbol method. Here you are taking hydrogen, oxygen and nitrogen. They are homoatomic because they have only one type of atoms. Here only hydrogens, here only oxygens and here only nitrogens. The atomic number is of hydrogen is 1, oxygen is 8 and nitrogen is 7. So when you write the electronic configuration, it is 1s1, here it is 1s2, 2s2, 2p, 4, here it is 1s2, 2s2, 2p, 3. So the valence electrons are equal to 1, valence electrons are here 6, here valence electrons are 5. So to get nearest inert gas configuration, this needs one more electron to get 2 electrons, this needs 2 electrons to get 8 electrons, this needs 3 electrons to get 8 electrons. So accordingly they share the electrons with the other atom. So hydrogen is with single electron, the other hydrogen is also with single electron. Oxygen, we write these 6 electrons as 6 dots this way, and this oxygen also will have 6 electrons. To differentiate only we are writing with cross and dot, but both are one and the same. This nitrogen will have 5 electrons around it because it has 5 valence electrons. So hydrogen gives only 1 electron. So this hydrogen contributes 1, this hydrogen also contributes 1. Now those two are shared among the two atoms. Now these are 2 electrons, that is 1 pair, belong to both the hydrogens. Such configuration is called duplet configuration. And how do we represent? With a single line. Similarly, if you look at oxygen, these 2 electrons are contributed by first oxygen, these 2 electrons are contributed by the second oxygen. So you see the bonding this way. So each oxygen is giving 2 electrons each. So these 4 electrons belong to both the atoms, that is 2 pairs. So the bond between oxygen is a double bond and the extra electrons are written as lone pairs this way. Similarly, if you look at nitrogen, nitrogen gives 3 electrons each because it needs 3 more electrons each for the stability. So 6 electrons are contributed by both the nitrogens, which is 3 pairs. So a triple bond you can see between 2 nitrogen atoms this way. Similarly, let us understand the formation of heteroatomic molecules like H2O and HF. So hydrogen here is with 1 electron and oxygen is with 6 electrons. So hydrogen needs to combine, oxygen can give 2 electrons at a time, whereas hydrogen can give only one electron. So we need two hydrogen atoms to give one electron each. So hydrogen with one electron, the other hydrogen is with one electron, and oxygen is with 6 electrons this way. So one electron is contributed by the hydrogen, one more electron is contributed by the hydrogen, two are contributed by the oxygen this way. So the bonding can be shown as oxygen 1 2 3 4 1 1 each. One hydrogen gives one more electron, otherwise I'll represent both the hydrogens with negative cross mark. Hydrogen, hydrogen, this is all together. So hydrogen is getting 2 electrons, this hydrogen also gets 2 electrons, that is duplet configuration, and this oxygen gets 1 2 3 4 5 6 7 8 electrons, that is octet configuration. This way bond is formed between the two oxygens and two hydrogens and one oxygen this way. This is H2O molecule. What about HF molecule? H has 1 electron, but fluorine has 7 electrons in the outermost shell. It needs only 1 electron. So both of them needs one electron. So the formula is HF. So hydrogen is with single electron, fluorine is with 1 2 3 4 5 6 7. So hydrogen gives 1, fluorine also gives 1. So accordingly hydrogen gets 2 electrons, fluorine gets 8 electrons. Duplet and octet, and hence the molecule is very much stable. Let us see the two most important limitations of Lewis dot model. Some molecules like BCl3, BeCl2, PCl5, SF6, etc. do not obey octet rule, where boron is getting only 6 electrons, beryllium gets only 4 electrons, phosphorus gets 10 electrons, sulfur gets 12 electrons. These are less than 8 electrons and these are greater than 8 electrons. So both of them do not obey octet rule. And how they are stable, that stability was not explained. Stability of these molecules was not explained by Lewis. This is one drawback. And the second drawback is it did not explain the shapes and bond characteristics, or you can say bond parameters, in polyatomic molecules like H2O, CH4, NH3, BF3, CO2, etc. In all these molecules, it did not explain the bond parameters and the shapes. Let us now understand the properties of covalent compounds. So covalent compounds are generally gases like the water vapor or carbon dioxide, sulfur dioxide, all these are gases, or volatile liquids like petrol, alcohol, ether, which can evaporate easily. Volatility means which can evaporate. And soft solids like coal, charcoal, etc. They are all very soft solids. This softness or the gaseous nature or the liquid nature is because of the weak van der Waals forces of attraction. So between the two atoms, the attractive forces are very much weak and hence they show low melting and boiling points. So you can convert them into liquids and vapors very easily with less heat, and hence their melting and boiling points are very much low. Now these covalent compounds are non-polar in nature. You cannot separate them into positive or negative charges, but we have seen few polar compounds also, and hence they are readily soluble in the benzene and alcohol. Benzene and alcohol are non-polar solvents. There's a saying that like dissolves like. So the medium that you are using and the substance that you are dissolving should have the same properties, then the solubility will be greater. So non-polar compounds will be readily soluble in the non-polar solvents. And these covalent compounds do not conduct, this point is very important, do not conduct any electricity, because when they are dissolved in benzene or alcohol, they do not form any ions and hence they do not conduct electricity. Covalent bond is a directional bond. You can say from in which direction, because along x-axis or y-axis or z-axis, in which direction the bond is formed between the two atoms, we can say it clearly. So the covalent bond is directional bond and it exhibits isomerism. That means one compound, suppose if you take C4H10, you can write this in multiple forms. One compound can exist in more than one different forms and hence such behavior is called isomerism. This is exhibited only by the covalent compounds but not by ionic compounds. Chemical reactions of covalent compounds are slow. In fact, it takes some months or years also for few reactions to be completed, and they can be reversible. That means the reaction will not be up to 100%. The reaction will be completed up to less than 100%. So these are the main properties of covalent compounds. So if we talk about the important questions from this topic is, what is a covalent bond? Definition, and explain the formation of covalent bond with 2 examples can be asked for 5 marks. But the most important question that can be asked is, discuss or compare the properties of ionic and covalent compounds. You can draw a tabular form and compare the properties of both ionic and covalent compounds. 5 points if you write, you're going to get the complete 5 marks very easily. So this is about covalent bond, its formation and important questions.